Thanks, Mike.
Hey, hey guys, we got no audio.
Mm.
Yeah,
Thanks, Mike.
that's what everyone's. So it's not coming through as we're seeing from the live stream. So yeah,
Hey,
all right, I'm gonna hop off and
hey guys, we got no worries. Hello, I'm Tyler Schuster, a developer. Oh, yeah, because I can hear you just fine. Okay, sounds good. Well, yeah. If no one heard that, Mike's having some problems with his audio, but I can hear him just fine. So, Urbit fixes this. No, but so he introduced me, which is just that I've been contributing to Landscape for about a year, primarily on the front end, which uses the React.js framework. And my day job is as a developer at 5paths, where I build websites and web applications for public agencies and nonprofits using a variety of web frameworks, including React and some of the other JavaScript technologies used in Landscape. So I'm going to talk today about JavaScript apps on Urbit. Like I said, I've been working on Landscape for a while, and Landscape is primarily based in JavaScript. But one common misconception is that Landscape is the official client for Urbit. That's more of a historical fact than something that's been by design. It just happens to be a JavaScript app that uses the JavaScript framework and a number of tools to communicate with your Urbit. And so that's something that I've learned as part of contributing to Landscape. So after a while of contributing on Landscape, I saw this bounty come up, which was for a TypeScript airlock, which I'll explain what that means later. You're probably familiar with TypeScript. That would allow anyone to use JavaScript to connect to Urbit's backend and write an app of this type. So I jumped at the chance, ended up developing it, and over the course, I came up with this idea for a browser extension, which I haven't had time to create. But the gist of it is that you can use Urbit's links backend to store bookmarks and other browser history in your Urbit. And so this is a good example of the kind of application that the JavaScript tools enable on Urbit. So I'm going to assume for the course of this presentation that you have some familiar with JavaScript ecosystem. If you're here, you know JavaScript, and if you know JavaScript, you know that it's mostly an ecosystem. So you'll probably know how to use some of these. At very minimum, you should know how to use NPM and React. So if you're thinking about building an app on Urbit, you probably want to know why you would do this. Let's say you're coming from context outside of Urbit where you may have just heard of it. This is an overview of why, and basically it's that Urbit handles the hard stuff. You get a lot of things for free using Urbit as the backend. You get authentication. You have your code, which is what you use to log into Landscape. That could be used to retrieve tokens for individual sessions. You get networking. You can communicate with other ships as long as you know their PAT-P. You don't need to know any sort of APIs or traversal. You can just send it to a specific address in Urbit. You get a lot of calculation and transformation for free. So you send it JSON and it takes care of where to store that, how to transform it. If you're using GraphStore, which is a great type of database for social information, such as Twitter or Reddit or any of the legacy services that we know and hate. You get all of these things for free. You get index calculation, you get sanitization, as long as it can be sent over HTTP, either it breaks or it succeeds and does all the sanitization itself. In general, security is not really an issue with Urbit. I mean, there are still some things being worked out because it's under development, but as far as I know now, there's not any holes, and at very least, it's not going to affect other ships. You may, if you create an application, the only ship that you open up for infiltration is your own, which is not something you have to, or which is something that you have to worry about with other frameworks, having your data compromised or allowing people to compromise other people's data. But if you know Urbit, you already know that is one of the benefits of the system. You also don't have forward. Oh, wow. Yeah, I'm going through a checklist here and forgot to share my screen. All right. It's okay. I've just been reviewing this slide. You also, the structure of your app prevents foreign code execution. So by default, the apps that ship with Urbit prevent you from running code. So if you were to create an app that received input from users, you don't have to worry about things like SQL injection. And more to the core of what we're going to be talking about today, you get a built-in API for every app through Gall. So you get pokes and subscribes and a number of things that you would have to build your own if you were creating an API on another service. So today we're mostly going to be talking about services that can be built using the built-in apps on Urbit, such as GraphStore. I won't go too much into the internals on those. You can build your own apps on the back end of Urbit, but that's outside the scope of this presentation. And then why JavaScript? The big thing is just that the browser is a ubiquitous UI toolkit, and you get a lot of stuff for free. You get the DOM, you get all sorts of utilities, you get networking utilities and interface things, and you get a nice box to run it in. It's, you know, it's a good thing for getting things up and running quickly, and everyone's in their browser all day anyway. Another reason, just that you know it, there's a lot of tools for it. There's a lot of resources out there. And there's also some tools that have come out of Landscape. So that's one of the things that I've been doing in the last year or so, is to extract some of the tools that the Landscape team has created and shamelessly poach them and put my name on them, although they are under the Urbit namespace, but they are just tools that the Landscape team developed. And I published at the Urbit NPM namespace. So in order to talk about how to create an app on Urbit, we have to first talk about the way that Urbit manages state, which will become clear in a moment. So with Urbit, you have, you boot your Urbit for the first time, and you say boot identity Zod, for example. And the kernel goes through a number of it does some calculation, and it ends up with state 1. And so here is the Zod Urbit, and for all time, the identity of that Urbit is built into it. So then input events begin to occur to your Urbit state. And so these can be from other ships, which is the AIMS vein, from the terminal, DIL, over HTTP, which is what we're going to be talking about today, or from any other app. So there can be internal things that happen to your Urbit state. Then those input events are processed, and state 1 isn't mutated, it changes into state 2. Now, I'm not totally qualified to talk about the specifics of this, but you have a series of events and you have states that occur, and then those produce effects that come out of that. So now your Urbit has changed from state 1 to state 2, and it's produced a number of effects, and we call these facts, that are produced on paths. So this is a general mechanism for how things work in Urbit. This almost everything should be pub/sub. It's just a screenshot of the third precept of Urbit, which Philip Monk has written. And this generally describes how pub/sub works in Urbit. Is on the left, you have any Urbit app, maybe a custom app, maybe a built-in one, and then it tells another Urbit app, the one on the right, that it wants to subscribe to a certain type of event. So both of these apps can produce effects, um, and so the app on the left produces an effect that says, tell this app that I want to subscribe to it, and then that app stores that subscription so that sometime later, when something else happens to that app on the right, it can publish the effect back to the app which subscribed. So again, this is what we call a fact. It's sent over a path. So this model is very important for everything that happens inside of Urbit, and also how you're going to write your JavaScript app when you get to the top level. So here's sort of an overview of Arvo, the Urbit OS. The little circles in the center are apps inside of Urbit. The circles on the edges of Arvo are the communication veins, such as AIR or HTTP, and those are modes of entry for events, and then they're also modes of egress for events. So if you want to build an Urbit interface, you have to have some sort of stack that both represents Urbit's internal state and then can manipulate it. So how do we determine which interface is shown? Well, the paradigm that React at least popularized, if not invented, was that interface is a function of state. So if you used React, you've probably come across this. And in general, what it means is that the interface being shown on the screen is determined exclusively by the backend state of the app. And this trickles down to components. So if you're giving a component a prop, as long as the props are the same, the component will render in the same way. So we have this state bubble over on the left, which is familiar from our review of Urbit. So if you have state 1, you have interface 1. Now, the interface is going to exist to send in new information to the backend. So our interface sends information to the backend, to Urbit. Urbit mutates into, or modifies into a new state, prompts a state change. And now that we have a new state, we have a new interface. So here's sort of a diagram of how Urbit and React are going to work together. So at the top, you have the state, it produces the initial effects. The interface receives those effects, waits for input, passes the input to the state acts upon that input, produces new effects, goes to the interface, which waits again to accept new input. So I think this is a really cool, it's synergistic, and you don't have to use React, but I'm going to use React to talk about this model because it's popularized this, and it works really well with creating an interface for Urbit. You get a lot of stuff for free as long as you set up your app to represent the parts of Urbit state that you want. You're always going to get something that reflects Urbit's internals. So let's talk about how to actually implement this in JavaScript. So you're probably familiar with HTTP grammar. Delete isn't on here because it's not really in the scope of what we're talking about, but you have asynchronous events, messages in HTTP, which are put and get. So a put request, you simply tell a foreign URL, here is some information. And on Urbit, this is similar to a poke, which I'll describe in the next slide. And you don't expect any information back from a put. Independent of that, you also have a get. So a get says, I want information from a certain URL. And given that you give it the same URL, you should always get, well, actually, that's not entirely true. But yeah, if you give it a URL, you're expecting a set of information back. But a get should always be idempotent. You should never modify information on the receiver's end of a get request. And then you have synchronous HTTP messages, and post is how you do a synchronous message. And a synchronous message is that you are giving a remote URL information, and presumably you're also giving it a method by which to modify or transform or act upon this information. And then you expect to have information returned from that. So that may be a modified version of the original. It may be something else. But in general, you can think of posts as having changed the state of the receiving end. So Urbit has similar vocabulary. These aren't strictly speaking equivalent, but for the purposes of understanding this, if you've never used these terms in Urbit, they're useful to understand. So a put is equivalent to a poke. Um, a put may change information, but you're not going to receive information back from it. So you're just saying, hey, other app, here's some information. A get is equivalent to a scry. So a scry says, I'm going to look into this URL and I'm going to see what information exists at that path. I won't modify any of it. And then you have synchronous operations in Urbit, such as a thread where, similar to post, you give it information, you accept a transformed version of that back. So again, everything in Urbit is pub sub. You have any Urbit app or an app on the outside. You send a subscribe request, you get text back. So we're going to be using the air vein in Argo. And the air vein is just what keeps track of HTTP handlers. It's a pretty simple. It basically acts as a it makes the outside seem to Urbit like an app on the inside. So it handles all the sanitization and authentication and things like that. So if you put a put request on air, it bounces around on the internals of Urbit, and then at some point later, you have a get request. So a put just receives a 204. It says, great, I received this. Then it does all these things. And then Urbit produces an effect to the outside world through air. And that's used, that's done via an event source. So if you've never used event sources before, they're similar to WebSockets if you've used those. But basically, it's just a mechanism for opening a channel to something that continuously produces a series of new events containing some information. So it's very close to the way in which Urbit produces effects internally. So this is why we call it an airlock. It's sort of a slang term, and it comes from the name air, but it also is an appropriate metaphor because it's this sanitization region on the outside of your ship that makes sure nothing coming in is able to malignantly modify the internal state. So in general, it's just management of data over HTTP. So in order to use an airlock, you make a post with your code to the login URL. And this is all that the login page on Landscape does. It just makes a post request using whatever code you put in the field. And then you get a 204 back, and all you get is you get a little cookie that says, here's your cookie for this session. It expires at a certain time, but that's going to be managed within Urbit. And this becomes your authentication token for the rest of your session with Air. So now you've done nothing but get a token. So you want to know about some things that are happening on the inside of your Urbit state. So you put a put request to this channel. And so this is going to be the URL of your Urbit. You have the SIG and then channel. And then this is just a random identifier. This is usually a timestamp with 6 hex characters on the end of it. That's just convention. It can be anything you want, but it needs to be unique because Air is going to give information back to the channel that it receives the subscribe request on. So this subscribe request, you'll notice you can do multiple actions. That's why it's an array. And then within those actions, within that array, you have actions. So there's always the action key. So in this case, we're subscribing. We're subscribing to the Graph Store app. And the path that we want to know about is updates. So this means every time Graph Store produces something that it considers worthwhile to produce on the updates channel, you'll get notified about that. And then you pass in your authentication token. So if you're in the browser, this cookie handling is actually taken care of for you. If you're in the node context, you're going to have to pass this cookie manually. So then Graph Store receives an update, produces an effect. Air receives that effect, notices that your channel has subscribed to it, and then produces an event source event that tells you that a graph update event has been produced, and the sort of the subtype is to add nodes, and then there's a bunch of information in there. So in summary, Air receives events from any app, not just the interface, and then it produces effects to outside channels which have subscribed. So if we're going to build an interface in Urbit, these are the parts that we need. So we've got our Urbit state at the bottom, and it produces some effects out. So we should have some sort of library for handling these effects, for managing channels, for managing authentication, for doing some sanitization and error handling. And then that is going to pass the information that it receives up here and over to the app state. So there should be some sort of container. You can just have window.state if you want, but some sort of management that represents a subset of the Urbit state in JavaScript. So then your interface should reflect what's in the app state, and the interface should accept events back, pass them to the API, and go into Urbit state. And then in order for some TypeScript support of the different data structures in Urbit, we should have some types. That's what this box represents. So these are the packages that I've been working on over the past couple months. This is the one that was originally a bounty. Now it's in the core Urbit repo. And this is how you can install it in NPM. And it's just this collection of utilities for managing error in JavaScript. You get authentication, it handles cookie management, it should handle cookie management on Node. It takes care of registering a channel, making sure that it only publishes and subscribes on that same channel. It tracks which events have been accepted, produced, and acknowledged. It handles event handlers. So if you want to do something when something happens on a particular channel of a particular type, you can register events using this library. And then it has little utility methods. So if you didn't have these utility methods, you just have to send the raw JSON. You said the action is this, the event ID is this, all the data is this. And instead we get HTTPI poke, and then it fills in the action, it fills in the event ID, and it transforms the rest of the data into the structure that a poke expects. So this is derived from channel.js. The landscape team has done most of the work. Shout out at least to Liam and Logan, who I know have done a lot of the work there. And Liam helped transfer the channel.js logic that was created in landscape to be part of this library. And then this is the other package, which I've created recently, or shall I say shamelessly poached. And this is all of the Urbit types that were that existed in landscape. So first you get some poke helpers. If you didn't have these poke helpers, you'd have to poke with the entire structure of what it takes to create a group. So you'd have to say, title is this, name is this, and you have to know the structure of the JSON that you're sending to Urbit. With the create group utility method that's exposed in API, it's written in TypeScript. So if you have VS Code or something similar, you just type create group, and it says it accepts 4 parameters. These are the shape of them, and it returns a poke interface. So for instance, that it's not a thread, and that the title is a string, the name is a string, the policy is an object of shape, either open or closed, and the description is a string. And then you get these TypeScript interfaces. So for instance, like what shape policy takes, what a path is, what a resource is, and you don't have to guess about a lot of these things. It still takes a lot of exploring, but the TypeScript completion really helps you with this. And you can just look at the code of the Urbit API package to help out with some of that, as well as looking at landscape, which is, again, where this was extracted from. And landscape now relies on this package for all its types, which means that if something gets added to landscape as part of the core, it probably will be available to you as well. ZooStand and Immer are 2 utilities which they're used in landscape now. Mostly it's ZooStand. Immer is sort of a support utility, but this is for state management. It's hook-based, which if you've had to do prop drilling before, you know how tiresome it can get to thread a single piece of data down from the very top level component all the way to, say, a chat message component or something. It might go through 10 different components which have nothing to do with that piece of data. It also means that if that particular piece of data changes, the entire tree doesn't have to re-render. It just re-renders the particular component that depends on that piece of data. And then you can also just make multiple stores in ZooStand. So you can have one store for each store on Urbit's backend, and that helps you separate some concerns and just makes it more legible. And then Immer is a set of utilities for making JavaScript objects immutable. And so this maps pretty closely to Urbit's concept of state, where you can't just change something about Urbit state. You have to tell it what the events that you want are to happen, and then it gives you back a new state. The original state isn't mutated. So here's one of any possible number of Urbit JavaScript stacks. These are the 4 libraries that Landscape uses that I would suggest just to get started with. As an alternative to the HTTP API, you could just roll your own. Go to this URL, and I wrote this as a part of writing the HTTP API. It uses curl as an example. It's very simple, just HTTP requests, and then you can write all the handlers yourself. Urbit API, it's really just nice. You don't have to use it, but if you like to code in the dark, that's fine. Or if you're familiar with all the structure of Urbit, that's also fine. And then we use React with pure functions and hook dependencies. So, okay, so strictly speaking, Landscape does have a few class-based components, but in general, you can create something that is a pure function, and then you just hook in the dependencies to the component that you're using. Alternatives, you can use anything you want, as long as you are familiar with the basic structure of how Urbit represents its state and transmits those effects. It doesn't matter what UI you use. And then ZooStand and Immer are we've picked them. They fit with the Landscape needs, but you can use any state library. You don't have to use a state library. You can prop drill all you want. But in the example that I'm going to show you, I use it because it provides some nice utilities. So to fill in our picture, we have React as our interface. It takes its information from ZooStand. ZooStand gets its information via some code that reduces via information received on the Urbit HTTP API, and the entire thing is typed using the Urbit/API package. So to get started using all of this technology, there is a create React app template at the Urbit org namespace. So you can run this command and get started writing something using JavaScript. So that's what I'm going to do right now. So first, I'm going to run that command that I showed you. And that's going to take a little while to download and install everything. So I'm going to go and boot FakeSod and a fake web, which hopefully should allow me to communicate with the FakeSod that I just booted. So now I'll go to localhost 8080, which is where the FakeSod is running. Get the key, which should just be the default. All right, so change into the directory we just created. So this is going to open up. This is just based off of the create React app template. So it's pretty simple. Now it says unconnected. So the first thing we have to do is to allow this origin to access it. So we can see that this is running at localhost 3000. This is just, we have to run cores approve http:/localhost. And this is just going to allow requests from the browser. We only have to worry about this on the browser because the browser cares about security and things like that. Okay, so now it's connected. We have a list of all of the messages that have been published on the app to which we have connected. So now I'm going to open up this app, and we can see this is going to be the app that Create React app is going to create for you. And we can see that we're connecting to localhost 8080 using this code, which is the default for a FakeSod. We've named the ship, and we've done some other handlers. So here I'll show you what gets created. So I'm going to start a DM with our friend Web. I'm going to say, well, let me pull this off to the right, actually, to the left. First, I'm going to accept this notification here on Web. So I'm using landscape here strictly as a reference application. Obviously, all the data is actually happening in Urbit. Landscape is not where this is happening per se. Landscape is just an application that's using the same technology stack that I outlined. So I'm going to say, hi web, and I'm going to watch this page. And there we are. So this is the React app that we've just created using this stack. And we have a list of the author, the date that it was sent, the channel it was sent in, and what was said. So if I go here, again, this is the same stack. It's received the information in the same way. And now to provide an example of poking back, I'm going to click this, and it's going to quote it back. It's going to say Zod said, hi web. So it uses the author and the contents and sends the message back to the channel that it came on. I'm going to say hi Zod here. Again, post to this channel. And now we have this author said this message on the same channel. So let's take a look at exactly how this is implemented. I've heavily commented this example, so you should be able to read through it to get more of an example, but let's talk about the individual parts. So here's the ZooStand and immer part. This is TypeScript again. So we have our graph store extends the base ZooStand state object or interface. And we're just going to store nodes. We're going to store all of the graph nodes that have come in, and we're going to key them by the string of the path they came in on with their index. And then we have a set function, which if we look down here, this is a produce function from immer, and this allows your state to be immutable, but it uses set to set it. Yeah.
One sec. We're having some issues with the aspect ratio in the Zoom. Can you just move your window in the screen, shift it so that the left margin is a little bit over to the right for what you're presenting there?
Like this?
Yeah, and I think that'll end up displaying things in the stream so everyone can actually see it all.
Okay. Just like that better?
Yeah, it's really a little left margin, and that should be better.
Okay.
Cool. We'll just kind of have to do that manually.
Okay. And then let me zoom in a little bit.
You can, the rest of the side of the screen is fine off to the right. It's just that.
Oh, weird. Okay.
So.
Okay.
Okay, cool. I'm gonna bounce off.
So this is the store that we've created for our app with a few utility functions to make it immutable. So we've imported that here. And we can just see that we've imported React. We've imported.
Go ahead and increase font size a little bit more too,
and
the height of the whole window there, and that'll be better.
Oh yeah, sure. It's just the left-hand side. So we make a few imports. We have our Urbit HTTP API, some helpers from Urbit API, and then this is all, let's see, well, this is the CSS. This is the store that I just described. And then we have a subscription and an event handler. So those get used here. So we have a create API function, and what it does is it memoizes a function with no parameters. So memoization means it memorizes the function, and that given the same input parameters, it produces the same output. So since we give it no parameters, what it does is it authenticates our Urbit, adds a few handlers, and then returns that same instance every time. It doesn't authenticate every time. So we have a stub of an error handler right here. So it just logs whatever happens to the console. But then we subscribe to this subscription that we defined in subscription.ts. So what this is just a simple JSON with a function on it. You're just saying, and this is the example that I showed in the slideshow. Here's the app graph store. I want to subscribe to updates path. And then here's our event handler, which is handle event. So when data comes in on this channel, because we've attached it to the graph store updates subscription, everything is going to have this graph update property because it's graph store updates. But we only care if the add nodes property is in, because we're just checking to see about all the nodes. So we get those nodes out, and we can type them using the Urbit API type. We get the resource that was given on the message because we want to store where those nodes came into. Now, we're not in the React context at all. So if we just run this set state object, React will never know about it because we're not hooking into it. So this batched updates function is what puts it back into the React lifecycle. So now we take the store, we get the current state, we use this immutable set function that we've attached as a utility, and it takes state as a parameter. And now we just loop through each of the new nodes. We get the node that's there. We just check to see if text is in the property. There are a couple different forms of node, but the text content is the one that's going to be sent via chat. And for purposes of this example, that's all we care about. And then we just put it into state. So this is this immutable thing where we don't even have to return state. We don't have to modify it. We just say state.nodes at this path equals the node that was created. So now we subscribed and we have our app. So this is our top level app component. As you can see, it's a pure function. So we hook into our node states. This creates a hook dependency. So if any of these nodes changes, this app is going to re-render. We have a connected helper because in order to see if the ship is running or has allowed cores, cross-origin resource sharing, we set connected to default, and then we create the API, which we're doing it for the first time now, so we're causing it to initialize. And if we're not connected, what we do is we go through and we get all of the messages that are already on the ship, and we set our connected status if we can actually scry for this this resource. So you can see here that this is a scry method that's exposed on the API. I'm going to write a little so you can see how the TypeScript interface works. So API.scry, there we go. We open it up. The params are a type of scry. We're going to open that up and see that we have an app property, which is a string, and a path property, which is also a string. So you should be able to go to the definition of that scry. Alternatively, we could do api.poke, and we see that it receives a number, and this is a similar syntax where it's where you poke an app and a path and a certain amount of JSON. So now we've handled this event. We've scried for all of the nodes on all of the paths, and we've gotten them back. And so this handle event, again, is the thing that sets the zoostand state. And so we can forget about it at this point because that will cause the zoostand state to change, which will cause the store to change, which will cause the entire app to re-render. And after that, all we do is we just take the nodes and we map them. We send them to this message helper, and the message helper is just a row with some columns. And then if you click on any one of these rows, it's this replier. So you click on it, it goes and gets the API connection that we've created, make sure that we have a ship. And that's just a type. We know that it exists at this point, but in order to make TypeScript happy, we return early. Then we go and get the path that we joined on a slash, and we assemble the text. So here you can see the text content has to have a text property. So there it is. And then we give it a string. This is another helper that's been imported from Urbit API, and this is create post. So you give it a ship, an array of contents, and then optionally a parent index, child index, and those are used for making threaded replies. And it's you can read more about GraphStore on the Urbit website now, on the docs. And then this is a thread, but we don't really need to wait for it to respond, because even though this will give us new information such as pending nodes, because when you send information to a graph, you don't necessarily modify the receiving graph, right? Because it could be on a remote ship. So you just get some pending information back. We aren't showing pending messages at this point, so we discard the result of this, and that's where this function ends. And so that's what allows us to do this message where we say, hello, friend. This uses the same stack on the landscape side to send the message to our Urbit. Our Urbit produces the effects, and now there are two subscriptions. Well, two subscriptions. Web has its own subscription. So landscape is subscribed to its own channel, and this app is subscribed to its channel, and they both receive the same effect that Air produces to them. So that's the core of everything that you need to build a JavaScript app. Everything after that is learning about which parts of Urbit you want to use. For most things, you're just going to use the Graph Store app because, like I said, that's a great way for representing social information. So you could write a Twitter clone or a personal notebook or any number of things. And you're also not limited to Landscape's particular implementation. You can create an Electron app that runs on your desktop without your browser running. You can create a Node app that runs in the background and subscribes to information. You can write a browser extension, anything where you can use JavaScript tools. You can use like one of these tools that I've outlined today. So the only caveat to be aware of is that this is not a script that you want to make available on a public-facing website because, as you can tell, it contains your code in the compiled source, and it has to because it's connecting to it. So we're working on some methods for authentication tokens that don't have to be exposed, can be revoked. I mean, you can cycle your code, but it's a bit of a tedious process. But it does open up this whole world of self-hosted utilities, where instead of connecting to some row in AWS or GCP's databases, you have your own database that's networked. It does all this data transformation on its own, and you provide a layer over it, and you could have theoretically a whole host of applications running only on your computer, on your Urbit. And then if you cloud host your Urbit somewhere or have a VPN into your local computer, you can access that from your phone or any number of clients as long as they can run JavaScript. So that's the basics of how to create a JavaScript app in Urbit. I'm interested to hear any questions you might have, and I hope you enjoy using this tool and the other tools that we've created. Okay, well, tell me what you want to say and I'll relay it. Okay, great.
Yep.
Hey, Josh.
Do that. Hey, Tyler. How's it going?
Good.
Well, cool. That was great. I think there was a lot covered there. This was good stuff. Sorry, everyone, about the technical issues that sometimes happen. It's one of those days. Let me see if I can go back. I think the very first question we had is, I might be missing some context here, but the question was, is it necessary to use Arvo for state transitions? I can maybe answer some of that, but I'll let you take that.
Unless you have a different answer, yes, I think there is a way to build on a lower level of Urbit than Arvo, but Arvo is generally the kernel of the operating system.
Yeah, I mean, Arvo is based on state transitions, so the whole Urbit OS works that way, and there isn't, for any practical purpose, a way to circumvent Arvo's state transitions, nor would you really want to, since that's one of the fundamental ideas behind the whole project. But I'm guessing that the question may have been more oriented towards the interplay between Arvo and Zustand.
Yeah, I mean, there is one possibility of that question is just that your entire app state does not have to come from Urbit. You can have internal state. I mean, like a modal, you don't send like you click a button that opens a modal, that information never gets sent back to Urbit. So that's internal app state, but that's sort of independent of Urbit.
Cool. Another question, I think is probably a pretty good one for this, asked by our friend Hunter, is about whether or not, or what the differences are between Urbit as a backend versus the other more traditional backends. I mean, I think it was phrased as, are there any major?
Are there any?
Are there any major differences
Oh.
between the backend versus some other more traditional backend stack?
Well, I mean, it's hard to say. There's a variety of different traditional backend stacks. So I was looking today at, or I was reminded today of this old JavaScript framework I used to use, Meteor, and Meteor actually has like a pretty similar model to Urbit, where it it opens up a WebSocket between the back end, which is running JavaScript, and the front end, which is running JavaScript, and they live in the same code base, so that's kind of cool. And so that uses the same model of PubSub. I think one of the things that you do get with Urbit is because it's so deterministic. There's a lot less sort of handling of edge cases or trying to figure out where something went wrong. I mean, it's possible that there are core bugs in Urbit. I'm not saying that the developers are perfect as much as I'd like to, but in general, because it's so deterministic, it's not like we wrote a try block without a catch and you accidentally got something. You So I think that's the biggest difference between Urbit as a traditional backend. One of the hard things about Urbit is that if you're trying to write something outside of the traditional, and not traditional, but a conventional data model such as GraphStore, you're going to have to implement that backend in Hoon, which is a whole different can of worms. But GraphStore is a great general purpose social database, and it works via these effects. So as long as you scry for the initial state and then you're subscribed, you just receive updates that occur after that, and Urbit takes care of most of that for you.
Yeah, I think that's right. I think one of the major general philosophical differences with Urbit and using it between a front end and back end is that the whole Urbit model is really heavily bought into the idea of PubSub, which is something that plenty of other stacks, I think, like you mentioned, similar to Meteor, have. But it's, in my experience, at least, not the default. Most people do not work with backends that are based on something like sourcing with server-sent events or WebSockets. Usually you're doing a more traditional request response type architecture.
Right.
And Urbit is explicitly not a request response architecture. It is PubSub, which is often for newcomers a new model to become accustomed to.
Yeah, definitely. Yeah, the threads and which are equivalent to HTTP posts are a relatively new. I mean, they may have existed for a while, but they're certainly gaining steam as convention in Urbit. I mean, everything is PubSub under the hood, but for a while in Urbit, it's actually been surprising that you actually got information back immediately. Which is, I think, more traditional architectures, you make a post and you expect that by the time the post has returned to you, it's manipulated all the data, or else it silently failed and refused to tell you anything.
Yeah, that's right. Yeah, Hunter just responded there. Perhaps RxJS would be a good fit here then. Yeah, I think any reactive type framework is a good fit here, and React is sort of one of those. That we probably use.
Yeah, I'm using React here, not because I particularly like it. It's just, I mean, it's fine, but it's well adopted and it has exemplified this particular model. So anything that uses that model, I say go for it.
Cool. All right, so we've got some more questions in here as well. There was one asked a little while back. I'm just going to kind of read it off to you here. It was a string of 3 posts from CS. We'll see if we can kind of figure out what he's asking here. But it says there are limitations in terms of which use cases can work in a true peer-to-peer model. Maybe. Is there a plan to utilize stars to handle more complex coordination? For example, contracts between plan and behavior? Or are most apps assuming that you just trust the page, but someone can then bypass that and use the command line to somehow cheat behavior.
Yeah, well, so like I said, this presentation was mostly about the default apps that ship with Urbit, and Graph Store, for example, is not going to allow remote foreign code execution, and Urbit is set up so that you can just deny a request from someone, and it's like you don't even exist. It's like there's no hole here. So if you create your own app and you allow remote code execution, then you've kind of opened up a security hole for yourself. The thing about Urbit that I think responds to this question is just that everything on Urbit is opt-in, essentially. I mean, we have to admit that there's a sort of base level of trust we have that Tlon isn't going to ship some code that's going to bork everyone's ships. But if I write my own custom app on Urbit, you have to install it yourself. And you have to allow whatever happens on there. So it's like, the current model of software distribution is like if you download an app, made by the Chinese government that allows a backdoor into your computer, then that's kind of on you, and you've accepted the license agreement for that. And so the story about software development in Urbit isn't well fleshed out. That's for sure. Like we don't know exactly how package management is going to work in a decentralized system, but that is something that we're working on right now, or the infrastructure team is working on right now, is how do we get these apps out? How do we allow for some sort of decentralized auditing where it's not like the Apple App Store where you just there's one entity that does it, but it's more of a social reputation. So these are questions that haven't been answered yet. There are plans to have stars do some of the more routing-like tasks. That's what one of the big things for stars. But as far as I know, there aren't plans for stars doing auditing. But there is the use case, and I'll finish here, is that a star provides updates to the planets under it, and so if I'm running a star and I say I really like this package, I think that everyone should use it, I could roll that into my distribution and then serve it to all the planets under me. I have an incentive to make sure that that's working, because then those planets will leave, and assuming that I'm charging them or something, they're going to not like that update because they can get the core distribution from someone else. And that was a discussion that was going recently on Urbit Dev, is how do we make sure that the core Urbit distribution is signed properly and then any additions are registered.
Cool. Another question. Have you done any, so yeah, there's some interesting history on this. Have you done any performance testing for scaling? Would a Twitter clone with hundreds of simultaneous requests have a bottleneck in one of these layers?
I can't answer that question. You should ask Liam. But basically, the bottleneck is going to happen on the host. And I mean, we've done performance scaling on Urbit Community, and then you guys had to shut down the host and scale it up because there were so many messages coming in. But it's not going to bottleneck on JavaScript per se. I mean, even if you get like Landscape currently downloads like I think Philip was saying like a 10 megabyte JSON package. So you can handle a lot of text in 10 megabytes of JSON. So I'm not sure about performance. It would have to happen on the hosts and not the recipients.
Yeah, there's kind of a bit of a, when you think about something like a Twitter clone on Urbit, what would that actually look like? Well, the performance considerations of something like Twitter are usually that Twitter is one organization that runs Twitter on behalf of every single person that uses Twitter in entirety. And so the way that they scale is by having to support every simultaneous connection all at once. With Urbit, everyone is running a protocol, and those protocols, that software that is implementing that protocol is just talking back and forth. And so you're really only needing to scale to the number of people that you need to communicate with directly.
Right.
So if, for instance, like Kanye were to get onto Urbit, and every single ship was like, I want to get subscriptions to this guy, he may have a problem. You know, this is where the scaling model will really come into play, is what happens when you have someone who is a celebrity and they are responsible for serving connections to every person that wants to hear from them. And so they have millions of subscribers, which is very different than your average person on Twitter, who probably has a couple hundred maybe.
Yes, but if someone didn't care about Kanye, they would not even be affected by his presence on the network.
That's right. So there will be scaling issues at some point when we get to that point. Okay, so we have some clarification from the person that asked this. Now I check back in. He means in error or in graph store. Is that where we, see any performance issues? I mean, yeah, I think the answer is the scale of any performance testing that's been done, to my knowledge, is just on the live network, and that I don't believe that there are any performance issues, at least within error. Or with GraphStore. I do know that when GraphStore was actually originally created, it was performance tested against more bespoke backends that were being used for chat and for publish.
Yeah, GraphStore can handle a lot of data, but the thing about Urbit is it's not like it receives requests and then that request just waits. So if it gets a whole bunch of stuff and it gets gummed up, those events are just going to wait to get processed and get processed, and then eventually they'll go through. I know it could happen that the person actually kills the Unix process, in which case I'm not sure exactly what would happen, but yeah, the only issue would be a slowdown, and that would just be due to like performance on the ship running it.
Yeah, cool. All right, well, that'll be our stab at that question. Seismic DNA is also still a little confused about Zustand, what it's doing in the front end and why it's necessary.
Oh, sure. Yeah. Well, so let's first describe a scenario where you don't use Zustand, and you just use your your global window object, and you have window.state equals, and then you have a giant JSON object, or even you have your top level React app, and it just has state. Like maybe even you're using a class component that has state, and it's this giant object that has all the nodes in your Urbit and all your settings, your invites, and then your top level app passes down little bits of those of that state to the children. So it says, so as you're familiar with in React, your component is based on the props that it receives. So let's say you just take graphs from your state and you put that into your graphs component, and then for each of those graphs you make a component for each of those graphs, and you say graph, and so you get some new information, you mutate your top level state, and you modify the small parameter, in this small graph. Then the change gets reflected all the way down. It doesn't have to re-render the middle components because those aren't re-rendering, but then the graph component re-renders. And so that's actually how Landscape was doing state for a long time, is it just had a big object up at the top. But the problem comes when you do all this prop threading. So if you have 10 different layers of components in between your top level and your bottom level, every time you want to write a new component down here, you have to thread it through every top level component. And then you get into some issues where there's shallow or deep comparisons that prompt a re-render of an entire tree when you only want to re-render the bottom component. So Zustand, it doesn't have to be Zustand, but it stands for hook-based state management. And it just says, I want to extract this particular part of a global state, and I want to re-render whenever that part changes, and no other components in the entire library have to worry about that particular state.
Yeah, I think the like Zustand is not necessarily specific to Urbit at all. This is just a problem of how to deal with state in large front ends, right? And every sufficiently complex single page application eventually has a whole bunch of information that needs to get shared in the application. Like Redux and Redux stores was an early attempt at this within the React space. It was component local state. There are some things that use cursors. There's a number of different approaches to managing state, and Zustand is, like you mentioned, a model that is emerging that works particularly well for hooks, which is a relatively new way of managing state.
Yeah, if you didn't want an additional dependency, use context would be an appropriate way to do this with utilities that ship with React. I've just found that Zustand is very elegant and minimal, and that's why we've used it.
Yeah, that's right. So we're at the top of the hour, so I think it's probably about time to do shut down the live stream and then move into the kind of happy hour section where if you didn't get your question answered, connect and say thanks, Tyler, or whatever. We'll paste the Meet link in that we're on, and you can come in and talk to us. With that, thanks everyone for coming. This has been great. Tyler, thanks for giving this. It's been
my pleasure.
It's been a great talk, and we're happy. It's good that you're demystifying this part of development. It's really
Yeah, I'm excited to see what apps come out of this.
Yeah, for sure. Tyler's very approachable. He's radbur-sivmus on Urbit. Drop him a DM. He's quite a helpful guy if you have any questions there. So thanks everyone, and we will see you in 2 weeks for the next developer call.